It will check if it is lower than the specified boundary. It will automatically. We have the smallest event cycle, as as I mentioned, it was 400. So, and the lowest, the minimum event cycle, it has 1,200 milliseconds. But because we have 3 readers, and when it will divide 1,200 into amount of this reader, each one will get the value of 400. But 400 is the lowest than our specified boundary, so automatically it will update the first event cycle to 1,500. So here we will have the first reader cycle. Each reader, each color represents each reader, and each color represents 500 milliseconds of reading. So in the first reading cycle of the first reader, we will have each one reading 500 milliseconds, and the same continues for the round 2, round 3, round 4 of the event cycle 1. For the second event cycle, in the first round, 3 of them will work some specified amount, and then it will keep the looping, it will keep orchestrating the readers like it's doing for the first one. So it will also, the logical reader 1 will have a second chance to read 500 milliseconds, but it's not creating a problem for our system. But in the next round, the second reader will read to this specified amount 2 times, so it's a fairly algorithm. And for the third logical cycle, reader cycle, for the first round, both readers will read 500 milliseconds. So, concluding my work, I will say that the reader collision problem is a key issue in RFID reader network, and it must be solved correctly in order to ensure the entire network to work properly. And the important thing in my work is that before this, the anti-collision algorithm was implemented in the reader hardware layer, and so far I have done some research. I haven't found any platform that is providing in the middleware layer the anti-collision algorithms. And solving collision problem, not also in the reader level, but also in the level of the middleware, it's very important. My solution was stated in the AIT's Automation and Computing Lab, and who wants, even later, after my presentation, I can present it to the lab, or I can present it also in my PC using the logical reader simulator. For the future work, we can say that we can also implement the situation like, let's say, when we have a neighbor readers. In these examples, I show that there are 3 readers, and the cycles is showing the field of view of each reader. They are 3 of them are neighbor readers, but as we can see, reader Y are colliding only with the second reader, and second reader are colliding with the third reader. So we can work in this situation. We can work in this way. First, we can implement a solution that reader 1 and reader 3 will both work in the same time, and after some amount of time reading, they will be stopped, and only the second reader will read, and in this way we can avoid also the collision problem as well. And also we can find a solution for the cases when one logical reader can be in multiple neighbor groups. Any questions?
So, what is the output of the simulator? Is it only this visual representation with the green and red lights, or you can also take some statistics or some textual output?
If we will test it only in the laptop, it only shows the light and the received messages. But also I made the simulator in the way that it can be, let's say, 3 of these lights can be, visual, and we can also connect to a reader that we have in the lab, and we can see there is a TCP message capture which is showing the received messages. And if we will pass, some attacks to the reader in the lab, we can see that it's reading and it's showing the results in the message capturer. But because I didn't create any, virtual tags that are passing through this simulator, you cannot show it. You can connect also. It has a capability to connect. One of these reader will be the real reader in our lab, and you can see how it works. You are welcome to present if you want after the presentation.
You can do that? No, you cannot do that through this laptop, right?
Only the laptop I cannot. If you want to see the received tags also, I cannot. If you want just to see how the simulator works, I can.
Another question? No? Nico? Okay. Thank you very much.
Thank you too.
You are done, you are finished, that's no more AIT or?
Probably I will take another topic to work with. I will discuss with Nikos to see. I like the stuff. I will try to implement.
No, I mean, MSIN is over? Or?
MSIN, I have one final exam on Monday, and this is it.
Okay, good luck.
Thank you very much.
Τελειώσαμε.